let's just remember all you're doing is you need to find 2 points, and then we're going to find the distance between those points. The catch is 1 point on a line, and the other point is off the line. Okay? But just remember, all you're doing is finding 2 points, and we're going to find the distance between them. That part's not hard. It's just determining what those 2 points are. Okay? So let's just see how this goes. Try to be with me during notes, and we'll go from there. Which segment? Focus. Focus. Okay. Which segment would best indicate the distance from point A to line R? So you see how many different options we have? We have AJ, AB, AG, AD, AH, and AC. There's only one. Why do you guys say AG?
Because it's 90-degree angle.
AG is the shortest.
Yes. So the perpendicular distance from 2 things, that is your shortest distance always. Okay? So today we're going to be using a lot of perpendicular slopes and whatnot.
Wouldn't it also be an angle bisector? Does that have something to do with it?
It could, yeah, it would. It cuts in half. Yep, exactly. Nailed it. Okay, so now which segment would best represent the distance from P to segment WZ? So find P, find WZ. Which segment best indicates that measure? You have 3. You guys agree? PD. So it has the right angle right here. Okay, let's try another one. J to WP. Which one has the right angle? JH. Yep. W to JP. There's W. JP. Which one makes the right angle? WJ. So do you guys see that?
Well, there's 2 different right angles. Why can't it be PJ or JP? Oh, wait.
So we're coming from W. And I want to get here. Which one makes the right angle? WJ or WP? WJ. So let's fill in these blanks here. The distance between a line and a point not on the line is the length of a segment perpendicular to that line from the point. This is the shortest distance possible. And the nice thing about this, there's only one that exists. There's only one line that exists. So some of the problems in your assignment today are going to take you like 2 seconds to do. Okay. That's the ones that we're going to do first. So it says on the coordinate plane, what is the distance between lines? Y equals 5 and y equals 1. So y equals 5, is that this way or this way?
Vertical.
Y equals 5.
What do you guys think?
Let me think.
Let's find 5 on y. 1, 2, 3, 4, 5.
So it's 4 parts.
So I need to go to that, through that point. Am I going to go through it like this or like this?
Vertical.
I'm going to go horizontal. Otherwise, I'd be going through 0 on the x. So y equals 5 is like this. So graph that. And y equals 1. Go to 1. Draw your horizontal line. So now what's the distance between these two? That's pretty obvious, right? You just have to count. 1, 2, 3, 4. Just 4. So when they're horizontal or vertical, they're super easy because you can just count. So let's try the next one. Same idea. But you're doing x equals. So your line's going to be vertical or horizontal?
Vertical. Vertical. The opposite. Opposite. So negative 3, 2 would be vertical.
That's just a point.
Oh, yeah. No. I don't know.
Different.
Boys, you gotta like focus today. You're not gonna talk over me or talk to each other, okay?
9.
So I need to find the distance from this point to this line. Can't I just count?
7.
No, because there's go through lines.
You have to
Would this be the perpendicular distance from this point to that line?
No.
Yes.
It should be. That's just a straight line.
Yeah, 7.
So we can just count. 3, 4, 5, 6, 7.
So it goes since it says x of 4, it's just any points?
It's just anything
Any point on the
next.
line? So what if it said 4, 0? Then would it have to...
So I go over
That's
4.
just a single point.
These are just points. It's not an equation. It's just a point. Before you had two equations, I had y equals 5, y equals 1, so the equations. This one, I just have a point. That's just a point. That's not an
I
equation.
just don't get how... It doesn't have to go like diagonal at all.
No, because what would be the perpendicular distance from this point to that line? It'd be right
It'll be
here.
right there. I was just saying, if the point, instead of saying x equals 4, if there's another point that said 4, 0.
So there's this point here.
No, it's where the x is right now,
Oh, yep.
just without the line.
Yeah, so then what would be your distance from that line to this point?
4.
4, 0 is right here, so what would be the distance from that red point to that green line?
I'm saying like the red point to the blue.
We'll figure
7.
that out.
Okay.
That's what we're gonna do. That's what we're doing next. So he's saying, how do I figure out if it's diagonal? That's what we need to learn. That's what we're gonna do right now. So we have a nice step-by-step process that's gonna help us figure that out. So it says line L contains points -5, 3, and 4, -6. Find the distance between point L and point P, 2, 4. So step 1 says find the equation of line L. So if I have 2 points on line L, because that's what we're given right here, what can you find right away? If I have 2 points.
The distance between them.
Nope. What can you find from 2 points on a line? We did it on Wednesday. Slope. We have to find our slope, right? So when you write an equation of a line, you need 2 things. You need your slope and your y-intercept. So first, let's find our slope. So how do we find slope?
X2 minus, or Y2 minus Y1.
Actually, it's over x.
You're close. You gotta flip them.
Actually, thought it was the other one.
Y2 minus.
First.
Yep, rise over run. So your y's go first. So if we plug in, we'll have -6 minus 3 over 4 minus -5.
Uh-oh.
So what is 6 minus 3?
-9.
-9.
Negative 9 over 9.
Over 9 is really
Negative 9.
-1. Perfect. So we have our slope. How do we find our y-intercept?
Y-intercept equation.
What equation did we do yesterday?
One slope.
Point
Y
slope form?
equals Y
minus
minus
Y1
Y minus Y1 equals
MX2
M times
x
X minus X1.
Yep. You gotta plug it in point slope form.
So you leave y and you enter y1. How do you?
So what point do you guys want to use? Do you want to use the first or second point?
Second.
Second. Second. Second.
That's fine.
So we're using the second point. So that's what I heard. So we're gonna have y minus,
6.
Negative.
so we really plus 6 equals, what's our slope we just found?
1. Negative 1.
-1 x minus 4.
Distribute.
Now we distribute.
Distribute. Know what?
Oh, now we gotta find the equation. And now you just
Yes.
subtract 6.
Perfect.
6, which
guys, we did it! We found line L. Woo!
We did it.
Easy.
So let's graph it to give ourselves a visual.
You plug in any X and Y.
So you got a -2 on the y-axis. So you put a point right there, and the slope is -1.
How do we graph this line? Where do we start?
Start with -2.
Start at -2.
And you can choose to write down the points it gives you.
You could. But what do we know our slope?
So
Negative.
take it.
-1.
So down one, over one, down one, over one. So give yourself some points. Yours will look way more accurate than mine will.
So we have come through all points. Oh, really? Oh, yeah. Sucks. Boom, mine's perfect.
Okay, so that's our line. And our point P is 2, 4. So let's just plot that quick. There's P. And our job is to figure out what's the distance from this blue point P to our line we just graphed. That's our job right now. So ultimately, we need to find the point on this line that's perpendicular to this point here, so I can have 2 points to do the distance formula with.
It's perfect.
Yeah,
Yes,
so
sir.
Like on the same line.
Yep, they will be on the same line. Yep. Yes, ma'am. If you want to. It's up to you. So let's go to step 2. It says write an equation of the line W perpendicular to line L that goes through point P. So what does my slope have to be if it's perpendicular to line L?
Plus X.
So our slope would be,
No.
so this is really -1/1, so if I flip it, it's still 1/1. If this is negative, it will be positive. So my slope's 1, and I want to go through point P, so 2, 4. Now we repeat that same process, y minus y1 equals m, x minus x1.
We repeat step 2.
So we're plugging in the point slope formula.
I got it.
Holy, why do you have negative?
Why do I have -4? Because my y coordinate is 4, so when I plug it in, it's -4.
Oh yeah.
Are you okay from there?
Yep.
Okay.
Look at that, they intersect that. -2, 1, 0.
Great. Are we okay with finding the equation of line W? Okay, let's graph line W just to see what it looks like. I gotta use a different color. So we're gonna go up to 2 on our Y and then go up 1/1. There we go.
They're intersecting.
Yes, and they should. If they don't intersect, then we definitely messed up. And it's a nice answer.
What does it mean if it's parallel?
Then they would not have it. Then we did something wrong, so you want them to touch.
What is this called?
Line W.
No, like. What
Distances?
did we just do? Like that equation?
Point slope form?
Yeah.
That's point slope form. Okay, so what is our intersection point?
-2, 0.
Okay, so this one worked out nice. We can clearly see that's where it intersects, but that will not always be the case, so let's do it algebraically so when that happens in your homework, you know how to solve it. So let's pretend that we didn't know it was -2, 0. How could we figure that out? Does anyone have an idea? Anyone have an idea? So when they intersect, it means they're equal. That's what they share, is when they're equal. So I'm going to set my two equations equal to each other. Aren't they both y equals y equals? So can't I substitute in? Yep. So if this helps, you put line L equals line W. Just so you maybe can reflect back on your notes and look. So if I look at my line L, he's here.
I think I got this right.
We didn't think you were going to be here.
I didn't think so
You're welcome.
Okay.
So if I look at line L, it's -x minus 2. If you look at line W, it's x plus 2. And now we just solve this. How do we solve that? You want your x's to one side.
So add x to left.
Plus x.
So it'd be 2x.
2x, right?
Yep, so it'd be -2 equals 2x plus 2.
And then you subtract the 2 from the right, so it'd be -4 equals 2x. And then that goes to -2 back. Oh, then that'll bring you right to the point where
X equals -2. So why is it -x minus 2?
Because it's line.
If it's -x,
Wouldn't you add 2 right off the bat?
You can
Or you're
solve it
setting up
different
your
ways.
Yeah.
So is that step 3 or 4?
This is still step 3.
I put on 4.
Okay. Did we want to get -2 for x?
Yeah.
Okay, how do I find my y coordinate?
Why?
plug it back in.
Plug back in. Can I plug into here? Find out what y is?
2 plus 2 equals 0.
So find
Zero.
y. Give yourself a little note.
Why?
Find y. So y equals -2 plus 2. Again, did we want to get 0 for y?
Oh, yeah.
So did it work out?
Yeah.
Okay. So now our last step says use the distance formula between points P and Q. Okay, what was point P? What was the point we started with? What's point P?
2, 4.
2, 4. What did we find point Q to be? What did we just find? -2, 0.
-2, 0.
Now let's plug into the distance formula.
Ooh. D equals.
Yep, do you remember it?
square root of
Yep.
something.
You're close.
Yeah.
Oh, no.
Oh, yeah.
We did this so much last year. I thought I was going to
This is the distance formula.
It's buggy. We did this all last year. I thought we were
That's incredible. I don't know why you do this in Algebra 1 and not Geometry.
We did this all the time last year.
Yes.
Did you honestly?
This is like.
In Algebra 1?
Yeah.
We didn't.
That's
We did
weird.
so much.
I teach Algebra 1 and we don't talk about it at all.
Miss Cretan like to get us a little advanced.
Sorry, Mr. Law.
That's incredible. So
So
then you
now
guys
it's
can do
time.
this then. Did you guys all go to the same school?
Yeah.
No, I went to Central last year.
You did not do this in
We all
Algebra
went to
1 last year.
No, we
No,
did.
you didn't.
In Salentine.
No, you didn't.
We did this.
I think you would know,
he's in the class.
We did this with Mr. Baker.
Yeah.
I'm pretty sure we did this with Mr.
David, did we do this last year?
Dylan,
No, we didn't do this last year.
Mr. Ross. Oh yeah.
You not, but
We did this with Mr. Law.
Law. I did it.
oh, Mr. Wall.
I did it.
We did
Okay, someone tell me what the square root of 32 is.
5.65.
Four.
Just the one. 6 point what?
7.25.
Thank you.
That doesn't make sense.
Yeah,
Yeah,
it's 6.5.
It's 5.5.
6.5 times 6.5.
It's 5.5. It's 5.5.
Did I hear wrong?
6 times 6 is 6.
I think it's the other way around.
5 and 6.
Hey Siri.
Oh,
shit,
5.7.
What is 32 squared? I mean 30.
It's 5.7.
5.7. Thank you. So if we look back at our graph, does it look like those 2 points are 5.7 units away?
Yes. 1.
Approximately from here to here?
Yeah, sure.
Yeah.
Actually,
Whew, that is a lot.
Where?
From point P to the red line. Does that look like it's about 5.7?
No, it doesn't seem.
1, 2, 3. It's about 5. Yeah. Okay. We're going to try another one, but you're just going to do it on your desk.